Man in black.
And then there's my friend who just likes to make people mad. He's like, what's your favorite country? I say 20 Rebel. Just to make people mad. Like, coming in. Weird dick. Buddy Holly. Cannibal Corpse.
Okay. Alright, guys. Some people have chosen to take longer breaks. They're going to miss out.
Oh, hell yeah.
Don't be excited about that. Screw this.
Hey man, live life.
Come on. I'm going to start talking. Don't worry, we're sitting.
Hello, Guten Tag.
I should not start recording. Sorry, recording. All right. A few more people. Okay. So, we're leaving chapter 8 behind. Chapter 8 was the confidence interval stuff. And we're getting into what normally students really, really love. You know how to interpret that. It involves testing claims, which is huge. I mean, you always hear about like a new drug or something and it says it's been clinically tested, clinically proven. This is what they're referencing, this idea of testing a claim. So a normal claim would be our product removes more bacteria than the old product does, or our drug will alleviate your headache symptoms quicker than the old drug did. Right? You with me? Now, of course, you guys should come in knowing a little bit about how they do that. Anybody know how they test a new drug out?
They tested it on animals.
No. All right. Depends on what it is. I love it. You don't have to be excited about that either. But yes, certain things have to be tested on animals first. This is true. But what if they're to the human trials? What do they do then? Yeah. Some people get a sugar pill, and they don't know it. Like placebo, you're right. Some people get the actual drug, and there's a control group. What's the control group get? Nothing. Just get stared at. Okay. You guys. So this type of thing would fall under what we're about to study. And this is called hypothesis testing. It should make complete sense. You have a hypothesis and you want to test it out. See if it looks about right. There's always a chance that your results are wrong. It's kind of built in. It's just the way life is. But let's say somebody has a claim that the average gas price right now is $3.51. And we take, I have no idea what it is, to be honest. I still haven't got gas in my car. We take 36 gas stations, and we find the sample mean of 358 and a standard deviation of 12 cents. Can somebody help me out? Is that 351? No. Is that, then can I just say that they're wrong?
No.
Why can I not say they're wrong yet? Okay, I like that. There's like a margin of error. This is only from 36 gas stations. This is only a sample, right? Yes, we expect a sample. In fact, you guys found that out earlier. You found that out, a lot of you guys. You expect the sample to be different than the actual population, whatever, in this case, mean. Are you guys, everybody still with me? Everybody still with me? So at some point, I always have somebody say, why am I doing all these steps? We found it wasn't the same, so why didn't I just stop there? And I'm like, oh my God. You only have a sample. So in order for this to show evidence that it isn't this, not only does this have to be different than this, it has to be different enough. It has to be like really different, right? So how do I start to get a feel for how different these are? And the way we, yes sir?
Go ahead.
Okay. The way we approach these tests is we assume the claim is right. And you've heard this kind of thing before. You say, assuming you're right, look what I just did. Right? Nobody can jump that high. Assuming you're right, and then jump, and then look at me. Right? So assuming you're right, look at this contradictory evidence. So we assume that that is true. So this is stronger than confidence intervals. I can construct a confidence interval and see if it includes this or not. But the confidence interval is based on sample data. So what we're really doing is we're saying, let's assume that this really is the middle. And why can I draw that picture in this problem?
It's 36.
Yeah, and it's 36, right? So I know the sample means are going to be normally distributed. So let's assume that that really is the middle. So where do we expect the sample mean to show up? Where could it show up? It doesn't have to be 351. We expect it to show up in some area around there. In fact, coming into this chapter, we would say if it shows up within 2 steps, 2 standard deviations, then I'd say that's not unusual. That's fine. And we should know by now, what is 2 standard deviations? What confidence interval is that related to? 95%. I love it. Right? Because there's 95% roughly within 2 steps. Okay. So I warned you before. It was 2 steps where unusual started before. Now it's going to have to be given to us. And there's something that we were talking about earlier. I keep forgetting to come back to. Quick side note. Somebody remind me, if I do a 95% confidence interval, what's the area in the tails? The total area in the tails.
0.1,
0.05. The symbol we give that is the little fish Greek symbol, right? It's alpha. Alpha is the area in the tails or tail if it's a one-tail deal. So alpha is always the area in all the tails. It could be 2 tails or 1 tail. Okay, I like it. So, knowing what we know coming into this, somebody help me out. How do I determine distance in statistics?
Standard deviation.
I use the standard deviation.
Z-score.
Z-scores. Z-scores tell me how far apart 2 things are. So how do I tell how far apart these are? I like it. Why isn't that good enough? They are 7 cents apart. That sounds like a lot. Oh well, too bad. That's evidence. No, that's not good enough. It's got to be relative. So how do I find the relative distance? I mean, what, like we just said, z-score. So how do I calculate the z-score in this case? Let's see if somebody's... All right. Divided by what now?
Standard
You don't
deviation.
divide by this. You don't. What do you have to do to this?
We change it.
You change it. Now, this is where some people don't follow. This is good for individual gas stations. I need the one that's good for every group of 36 gas stations, so I have to change it. And actually, I love the way the calculator, didn't the calculator tell you this, SX? So it is telling you, oh, you haven't made it SX bar yet. You haven't changed it yet. That's the one that's good for individuals. I have to make the one that's good for groups. So I got to take 0.12 divided by root of 36. So divided by 6, so you get 12 divided by 6. Yes, that's my new standard deviation. So that's what I divide by. And what do you get when you do this?
3.5.
Yeah, you get z-score of 3.5.
Is that high?
Does everybody follow? This is old news here. This is the one that's good for individuals. I got to change it to the one that's good for groups of 36. Then I can make a z-score.
Wasn't the z-score equation x minus the mean?
Yeah, so it's
351 minus 358.
that's our data minus the mean.
Oh,
Yep. We always go into the test assuming this is the real mean. Okay. So let me go back over this real quick. So somebody had a claim and went, okay, let's assume you're right. Let's assume that's the way it looks. So what should be true about getting out here? It should be really hard to get out there, right? It's really unlikely to get a sample out there if that's in the right place. So what did we do? We got a sample of 358, and now we know it is where? Where'd that end up on the picture? Way the shit out there, right? Now that we calculated the z-score, we know how relatively far away. It's 3.5 steps up. What do you guys feel about that? Was that expected to get that? If that's in the right place, is this an expected value to get? You guys can do it.
No.
No, it's not. Because it's not where I would expect it to be. It's 3.5 steps away. That's really freaking far away. Do you guys get the idea of that? Hopefully at this point you should all understand that 3.5 steps, the z-squared 3.5, that's really freaking far away. Because for a normal distribution, how much is in 3 steps? It ends out to be 99.7% is within 3 steps. This is 3.5 steps away. All right, I like it. So it's sort of like if somebody said, it's impossible to win that claw game, and I went over and I won the claw game. I'm like, well, that sort of destroys that. So assuming you're right, look what I just did. So that's contradictory, you must be wrong. So let me go over it one more time. Assuming this is in the right place, it should be really, really unlikely to just randomly pick a sample that's out here. And then what do we go and do? We picked a random sample that's out there. So what's more likely? We just happen to pick a bunch of expensive gas stations? Or this is in the wrong place? More likely that this is in the wrong place. In fact, I could be really specific about, this is interpreted wrong all the time, but I could figure out the approximate probability that I would get out here. What's the area in the tail of this guy? What's the area in here? And somebody help me out. The z-score is 3.5. What's the area out there?
It's going to be 1 minus 0.999.
Yes, that's 0.0001. That is the rough probability that this would have happened if that is really the center. So what's more likely? That isn't really the center. What's more likely is the picture looks more like this somewhere. The mean is actually bigger. Okay, hopefully. So this continues that thing I told you that was going to start in chapter 7. It's bringing everything we know into one problem, right? Oh shit. This here, this value right here, this is called the p-value. And it's p-value because it's the probability that what we saw happened just randomly. So normally, the most commonly used benchmark is if this is less than 0.05, it's evidence that this is not right. And this is way less than 0.05. Right? Okay, any questions at the moment? Yes, sir?
Is it 0.0001 because it's on the right side?
Totally.
Yeah.
So I want to know, what's the likelihood of getting something where this is? So in the area where 3.5 z-score is, that's 0.0001 chance to be out there. That's the probability. So that's more than likely not the real mean. Now again, like always, there is a chance that my conclusion that I just made, that that's not the right mean, there's a chance that I'm wrong. But the chances of that happening are roughly related to this. 0.0001. That's way better than normal for me, for probability of being wrong. Yes?
So if that's not the real mean, then what is?
That's the problem. You don't know. What do I know from this little quick study we did? It's more than this. That's all I know. Do I know that it's this? Oh, hell no, because again, this is just a sample. But this is a way to gauge if something has changed. Or, like if you're in a nuclear reactor, again, I love this example. There's a benchmark amount that's something, the pressure or whatever. So you can do a hypothesis test. You can program a computer to do this hypothesis test and say, have I varied enough from that parameter to make this guy get off his ass? And I'm going to make a little beep, 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 right? Or like a wah, wah, depending on what the shit, how bad it is. You guys kind of with me? So it doesn't mean that value has to come from somewhere. It could just be something we set, and if I get far enough away from it, I'm like, oh shit. And again, what's the key thing I just said? Far enough away. That's what stats is really good about. how relatively far apart are two values. Okay. All right. Now, really want you to understand everything we just done is just talking about the idea. The actual work is going to be it's going to be a 5-step. I'm going to give you the steps. When I was taught it was 8 steps, so you're welcome. Before I forget, the homework for this section references a worksheet in the back of the book. Screw that worksheet. You're going to do, because they do the same stuff just out of order, because they do it all in the calculator. So screw that. You're going to do the 5 steps on the handouts I'm going to give you. You'll answer the same things just in a better order. Okay? So just don't use the worksheet they talk about in chapter 8. Chapter 9. Don't use that worksheet in the back of the book. Screw that. Okay? All right, maybe. So let's come back and formalize a few things. Let's talk about what these steps might be. I'm going to come over to this side, I think. Let me leave all that work there. Okay. Somebody help me out. What's the claim that was being made? I put the word claim there, so it's not hard. And now put it in symbols. Use statistical symbols for the claim.
So
Mu
equals
equals 3.51. Beautiful. So in a problem, it's going to say, we feel that the average credit card debt is less than $1,200 or something. That would be mu less than 1,200. That's the symbols. Okay. Now, what are we trying to do? What does it feel like we're trying to do always in a test like this? We're always trying to show evidence that this guy is wrong. You with it? Because we always go, okay, let's assume you're right. I'm going to go try to show that you're wrong. I'm going to go try to find contradictory evidence. So do you understand that? That means there's 2 sides to this, right? There's 2 positions. This one and the opposite. You're going to love this. We call this one, not the claim always, the claim could be either one. We call the thing we're trying to fight against, or the thing we're trying to find evidence against, we call that the null, H-O, affectionately known as the hoe. Feel about that however you want to, but it just makes talking about this a little more interesting. It's been a while since I had somebody actually get offended about it.
No?
So,
No, that's the 0 at the bottom. No.
okay. The null will always include equals somehow. So it could be just equals, it could be less than or equal to, it could be greater than or equal, because the null has got to be the guy that thinks it's somewhere in here. And we're trying to show evidence that it's far away from there. So the null, if your claim was it's at most 7, that would be mu less than or equal to 7. That would be HO, because it has an equal sign in it.
Just out of curiosity, what are the H? Is it H and O or H and 0?
Well, it's H0.
Okay.
Yeah.
What does the H actually stand for?
Hypothesis.
Okay.
Yeah.
And the 0 meaning?
Null. Yeah. That word null is related to 0.
No, I know that, but I mean, why is it? What is that null reference?
It's kind of like the original stance. So you can even think of O as being original. I used to use a book that called the next thing HA for alternate. This book and a few other books uses H1.
So it's kind of like the 0 is kind of like saying like H naught kind of idea. Like
Yes,
the
H naught.
yeah.
This is how you pronounce that, is H naught.
Got it.
But it's called the null hypothesis. And then the other one, the opposite of that, we call it the H1, or I call it the high. So you got the hoes and the highs. This is the alternate hypothesis. It's H1. And what would the alternate be here? It's got to be the opposite of the first two. No, never. There's never going to be sample data here, because before you go take a sample, you make a claim.
Mu is not equal to?
Yes, so what's the opposite of mu equals 3.51? Mu is not equal to. Okay, cool. I like this. I like this. It's too bad.
Only I matter.
So, step one is the hypothesis, setting up the claims. Step one is actually, what the hell are you talking about? That's step one. Step two, now we did some stuff down here. Why was I allowed to do certain parts of this? Why was I allowed to do this? Why was I allowed to look that up?
C-score.
Why? Why is it normal?
Greater than 30.
Yeah, and it's greater than 30. Okay. So the second step, this is what I'm going to talk about, and before I actually analyze what I'm going to talk about, I got to know I'm allowed to do some shit. The second step would be, can we use, or let me say it this way, do we use Z or T or nothing?
For this part 2 of step 1 or step 2?
This is step 2.
Okay.
Let me make them 1 and 2. 1 and 2. So what are we talking about? What are we allowed to use to talk about it? When would it be nothing? Well, if n was less than 30 and it doesn't say that it's normal, I'm officially not allowed to do this. I would never give you a problem where you'd have to do all 5 steps if you didn't notice something. I mean, that would be so evil. Holy shit. Maybe 10 years from now I'll be all like, screw all them screws. You know, I'm not quite there yet. Now, what? So again, here, what was it that told me I could do a z-score? Or in fact, what did we use? We should have used a t-score, right? Why a t in that case?
You just don't know.
Because we don't know sigma.
Yeah, sigma unknown, but n is greater than 30, so that tells me I can do something. And then which standard deviation do I know? Tells me z or t.
It's mean, or sample standard deviation.
Yeah, this one was a sample standard deviation, so I had to use t. So this step is really familiar. If I was talking about percentages, what would I check here? NP, NQ. I like it. We'll get there, don't worry. There won't be any hats there. We'll talk about why later. All right, I like it, I like it. So this step is related to, is it normal enough? And we've seen that quite a few times. So that's all this step is. I like it. The next step would be, the next step is interesting.